Okay, so these are questions here. There are 30 multiple choice questions. We're going to try to answer all of them. Okay, so if you don't understand anything, please feel free to ask. Okay, all right, so we start with question one. They're saying a population, okay, and then they have put different options there. Okay, so option A, they're saying a population is the number of objects of interest. Okay, B, a population is the number of elements of interest. And then C, they're saying a population can be divided into samples. And then D, they're saying all of the above. Okay, so anyone who can help us, which one is the best answer there? Which one do you feel is the best answer there on the options that we've been given there? Though, any,
D, all of the above.
yeah, so there, all these here tick what a population is. Okay, it's the number of objects of interest, yes. It's the number of elements of interest, yes. Can be divided into sample, yes. So the best option there will be all of the above. So that's what you choose as your answer there. Okay, and then two, they're saying which of the following is not true about the median? Okay, A, it is a measure of central tendency. Okay. And then B, they're saying it is a measure of position. And then C, it is a measure of spread. Okay, which one is not true? So the one which is not true here is C. It is a measure of spread. Okay, that statement is not true about the median. The median does not measure the spread. Okay, the things that measure the spread, it's like when they ask you to find the range, okay, or they ask you to find the variance, or the standard deviation, those measure the spread, okay? But the median does not measure the spread. But it's a measure of central tendency, okay? That we all know. And then it's also a measure of position, okay? Because it's going to indicate where the middle value for that data set that you've been given is, okay? It's going to point to the position where the middle value is. So the median is also a measure of position, and it's the measure of central tendency. Okay, so you choose C there as the best answer. Okay, question three, they're saying mode, mean, and median are similar because, okay, so here you have to be very careful because all the answers are sounding correct. Okay, all the answers are sounding correct, but we are trying to look for that best option. Okay, all right, so A, they're saying they are all measures of position. Okay, they are all measures of position. Okay, so the median is a measure of position, quite all right. Okay, because it's going to point um, at the position where a certain value is. Okay, where the middle value is. It's a measure of position. But when you talk about the mode and mean, they're not necessarily measures of position. Okay, because the mean will give you the average. Okay, and then the mode, it will give you the most frequent value. Okay, all right, so this option we cannot accept. Okay, and then they're saying they are all averages. Okay, are they all averages? The mean is the average, yes. Okay, but the mode and the median, they are not average. Okay, so we're going to say no to this. And then they are all central data representative. This is true because remember, the mean, the mode, and the median are measures of central tendency. Okay, so meaning they represent a typical value in a data set. Okay, so this one is true here. What about D? D, they're saying they are used in comparison of data sets. Okay, yeah, it can be true. Okay, it can be true. They are used to compare data sets there and there. But in this case, the best answer is that they are similar because they are all central data representative. Okay, they are measures of central tendency. So we are going to pick this C here as the best answer. Okay, we go to question four. Question four, they're saying if events A and B are independent, then, okay, if events A and B are independent, then this one is just the definition of independent events. Okay, so the correct answer there is D. If A and B are independent, okay, then their intersection will be equals to the multiplication or the product of their individual what probabilities. Okay, so we pick D as the best answer there. Okay, so guys, if you have any question, please just ask. Okay, and then 5, we're saying histograms and box plots are similar because they. Okay, so maybe let's draw this thing. So the box plot will be this guy here. Okay, and then the histogram will be something like this. Okay, so that is the histogram there. So now they're saying these two are similar because, okay, so what you get from the histogram and the box plot, okay, you get to know the distribution. Okay, how is the data that you've been given, how is it distributed? Okay, is it skewed to the right or is it skewed to the left or is it symmetric? That's what they show us. Okay, so if I was to draw a rough sketch, okay, around this histogram like that. Okay, so we see that this guy here will be a bit skewed to the right because it has a slightly longer tail than this one on the left. So it just shows us the distribution of the data that we have. And then even in the box plot, it's the same. So you just compare these guys here. These guys are called whiskers. Okay, so the side that has the longer whisker, okay, we are going to say the data is skewed to that side. So if my right hand whisker, this one here, if it's longer than the whisker that I have on the left, then we are going to say this data is right skewed or positively skewed. Okay, so both the box plot and the histograms, they're just going to show us the display of the shape of the distribution. Okay, so there we are going to pick which answer now? We're going to pick A, right? Yeah. So because they display the shape of the distribution. Okay, so we'll pick A as the best answer here. All right, and then these other options are wrong because here, like for example, B, they're saying they show quantitative and qualitative. This is wrong. For the qualitative one, then we should have a bar chart, which is like this. Okay, so you should know the difference between a bar chart and a histogram. In the histogram, there are no spaces between these bars. You've seen there. But in a bar chart, this is the bar chart here. There are always spaces between. And the bar chart is used for qualitative data. And then this histogram is used for quantitative data. Okay, so uh, just keep that in your mind in case such a question comes. Okay, and then let's look at question 6. So question 6,
I have a
someone has a
question
question?
on
Yes?
question 5.
Yes, you can ask.
What kind of data does a box plot represent?
What kind of what?
What kind of data? Like, is it quantitative or qualitative?
It represents quantitative.
All right, thank you, sir.
All right. So for the box plot, you have to have numbers. So your data should be quantitative numbers. You find the maximum, something like that. Okay, so it's quantitative. And then 6, what are they saying here now? They're saying find the probability, okay, of an certain event, of an uncertain. Okay, find the probability of an uncertain event in a selection of 6 pins from a box of so here I made a mistake when typing. So this here has to be in a box of 1 pins. Okay, not 10 pins there. So the uncertain event, what is the probability of an uncertain event? If if an event is uncertain, what is its probability? Anyone who can try.
I think It's supposed to be zero since it's uncertain. It's not known.
Yeah. So the probability there is wait. When we say uncertain, then don't we mean the probability is zero? If something is uncertain, you are sure that okay, this is uncertain, it's not going to happen, then the probability is zero, right? Okay. So when we say the probability of an uncertain event, um, in a selection of 6 white pins from a box of 1 pin, they are supposed to type 1 pin. I made a mistake. I wrote 10 pins. So what would be the probability of selecting 6 white pins from a box that has 1 pin? It can't work, right? Because if this is a box here, it has only 1 pin. Then I want to select 6 pins from this box. It is impossible. Okay, it is impossible. It can't happen. Okay, so the probability there will just be what? Just be zero. All right, so the answer that you said there is correct. So we choose A there. The probability is zero. And then which of the following is not necessary for a discrete random variable to be valid? Okay, which of the following is not necessary for a discrete random variable to be valid? Okay, so for a discrete random variable to be valid, first of all, we require that the probability px, okay, of any event should be between 0 and 1. And it's the same again even for continuous random variables. And then for discrete random variables, okay, we require that if I add all the probabilities, okay, this is the summation of all the probabilities, then I should get a total of 1. Okay. So these ones here are the 2 most important things for a discrete random variable to be valid. But now let's look at our options. So this one, we've defined it there. This one, we've defined it there. So now I want to look for something that is false between this A and B. Okay. So which of the following is not necessary for the discrete random variable to be valid? Okay. So this one here is just the formula for finding the mean, okay, under discrete random variable. You say the summation, and then you multiply each of those probabilities, okay, by its x. So this guy here, it can also be considered as it has to be like that for this discrete random variable to be valid. But for this one here, for the first one, they're saying the summation of all the x values should be equals to 1. This one here is false. Because remember when we draw something like a table, okay, the distribution of a discrete random variable, we can say this x is 0, 1, 2. So when we sum all these, they're not always equals to 1. Okay, so this guy here is false. So we're going to pick it as the answer here. Okay, so the summation of all the x are not necessarily going to be equals to 1. No. Okay. Unless you just have 2x values, 0 and 1, then they'll sum to 1, yes. But if you have 0, 1, 2, 3, they won't sum to 1. So this one here on A is not necessary, okay, for a discrete random variable to be valid. So we pick it as the answer there. Okay. Where's my eraser? And then part 8, they're saying discrete random variables have a probability distribution code. Okay, so we all know that that's the PMF. So probability mass function. Okay, so the probability distribution of discrete random variables is PMF. And then if it's continuous random variables, it becomes PDF. Okay, but both the PMF and the PDF, they have the CDF. Okay, but the PMF strictly under discrete random variables. PDF, continuous random variables. Okay, I hope that's clear. And then question 9, they're saying if the probability of success in a binomial distribution is denoted by P, the probability of failure is, okay, this one is very easy. The probability of failure is just 1 minus P, which we said was equals to Q. So you go on that option, you pick it. Oh, so here I didn't say PMF is on option D. Here, 1 minus P is also option A. So that's the answer there. Okay, what about question 10? Question 10, they're saying, what is the probability that one event occurs, okay, in um, a Poisson defined by a characteristic lambda? Okay, so here a Poisson doesn't make sense because if X follows a Poisson, then um, its formula will be e to the power minus lambda, then uh, lambda to the power, maybe it does make sense. Okay, lambda to the power. Okay, let me write it like this. So if I have X, which is following a Poisson, okay, then the PDF that X is equals to a certain value K will be equals to e to the power minus lambda, and then lambda to the power K divided by K factorial. So now here they're saying, what is the probability that one event occurs in a Poisson distribution? Okay, so meaning that wherever there's K, I put 1. So it will be probability that X is equals to 1 will be equals to e to the power minus lambda, lambda to the power 1 over 1 factorial. So this will just be lambda, then e to the power minus what? Lambda, like this. Okay, so we're just looking for something like this on the options. So we see it's on option A. So we pick A there as the best answer. Okay, let's now look at let's now look at question 11. So I think the first random quiz ended on question 10, and then from question 11 to 20 it was another one. Yeah, so we start from there now. So here, question 11, they're saying a uniform distribution is defined on the interval A to B. Which of the following is the correct formula for its PDF? Okay, so if X follows a uniform distribution, okay, on the interval A to B, or on the parameters A and B, then its PDF, f of X, is just simply equals to 1 over B minus A. So we're looking for this on the options. Okay, so I see it on I see it where I see it on option A. So I pick A there as my best answer. Okay, I hope you guys are seeing this. These are just simple questions, okay? Nothing more computational. They're just asking you concepts or formulas. So which of the following is the standard deviation of the uniform distribution? Okay, so to know the standard deviation here, we just have to know the variance. So the variance, okay, under the uniform distribution is B minus A to the power 2 divided by 12. So now if I'm finding my standard deviation, lambda sigma, it's just going to be equals to the square root of these things. So if I do the square root of that and the square root of that, this and this cancels, so I remain with B minus A over the square root of what? 12. So you have to know this formula, guys. Okay, so the standard deviation is given by this formula. So you check on the options there, which one resembles this one. So question 12, it's on A. So I'll pick A there as the formula for the standard deviation. Okay, so now let's look at question 13. So question 13, they're saying which of the following is the defining property, okay, of an exponential distribution? Which of the following is the defining property of an exponential distribution? Okay, so we have the memory-less property there. We have that it considers average of time of events in time, and then they have just given the PDF formula that it has there, and then the mean is equal to the standard deviation. Okay, so all these answers are true here, but which one is the defining property? Okay, so under the exponential distribution, we know that the mean is equal to the standard deviation. That's true. Okay, this one is the PDF for the exponential distribution. That's true. And then it considers average of time in or average of events in time. That's true again. And then now memoryless property. So the memoryless property is the defining property of the what? Of the exponential distribution. But what is the memoryless property? Okay, so by definition, in just words, you say that the memoryless property, okay, or you say that a random variable is memoryless if the probability of an event occurring in future, okay, does not depend on how much time has already passed. That's what the memoryless property states, okay? Simply meaning that it just simply tells us that we should forget the past, okay? It forgets the history. It just depends on the current state and not the past. That's what the memoryless property states. But maybe they can ask you to state it in terms of a formula, okay? So you just say P, or the probability that X, okay, has exceeded S plus T, okay? So this is specifically when you consider the exponential distribution. So the probability, okay, that the waiting time, this Y here is the waiting time. The probability that the waiting time X here, why am I saying Y? Okay, the probability of this waiting time X is greater than S plus T, okay? Given that, I'm supposed to put given here, not now. Okay, so the probability that the waiting time X has exceeded S plus T, given that X has already exceeded S, okay, is the same as the probability that X has exceeded T. Okay, so in case they ask you to state the formula, you state this guy here. Okay, so, but in the actual meaning, just means the probability, okay, that the waiting time exceeds S plus T, given that it has already passed or exceeded S, okay, is the same as we're just starting from the start, which is this statement, which is given there. Okay, so that's the memoryless property there. Maybe they can ask you a question there. And then we move on to question 14. Question 14, what does it say? Okay, so question 14, they're saying uniform and exponential distributions are similar because, okay, so remember if X follows a uniform, then it will be defined on two parameters, A and B, okay? And then when X follows, okay, an exponential, then it will be defined for this parameter lambda, and this parameter lambda should be greater than 0. Okay, so what is the similarity do we see between these two distributions? Okay, is that in the uniform distribution, okay, the X depends on the parameter A and B. Okay, and then in the exponential, the X only depends on this parameter lambda. So in the uniform, we have two parameters A and B, but in the exponential, we only have one parameter, which is lambda. Okay, so the best answer that we can pick there would be it's defined on specific parameters. So we pick this guy here. Okay, so that's the answer there. Unless you guys have questions. Okay, what about question 15? Question 15, they're saying, what is the probability that a value is less than 2 standard deviations from the mean in the standard normal distribution? Okay, so this less than 2 standard deviations from the mean in a standard normal distribution simply means the probability that Z is less than 2. Okay, so this 2, we can write it as 2.00. So you just go to the Z table and then get this probability. We know how to get this, right? So let me go there. So if I go to my Z table, this guy here, okay, what is the probability that Z is less than 2.00? So in this first column, I'm just looking for 2. 2 is there, okay? So it means in this first row, I'm looking for 00 here. So I'm coming down in this column here, and then I'll meet there. So that is the answer there. So 0.9772. So here, where am I? Okay, I'm here. So this is 0.9772. So you check your options. If you have that, you see it on D. Okay, so the key here is to understand what this statement here means. If we understand that, then we're on good. All right, so now let's move to question 13. 16, not 13. Okay, this one here. So this one is a bit tricky. If you've never seen it before and you don't understand the language, you can't solve it. Okay, trust me. You just guess it if you get the answer correct. So they're saying about 38.3% of data in a standard normal distribution for Z. Okay, so they have given us the probability. Okay, whenever they give you a percent, that's the probability. So 38.3 divided by 100. Okay, it will give me 0.383. Okay, so that's the probability that they've given us there. So they want us to find how far is it how far from the mean does this probability fall? Okay, how far from the mean does this probability fall? So if you have no idea how to do it, you can just go option by option to see which one will give you this. So the first one, they're saying less than 0.5 deviations from the mean. So there they just simply mean the probability that Z is less than 0.5. So the probability that Z is less than 0.5, okay? If you go on the normal table, what is it going to give you? So 0.5, it's here. And then 0, is there. So it's this value here. So that is 0.69146. Okay, so I'll come, where's my, okay, I'll come here and put it there. So that is just 0.691. It was 146. I'll just write 5 there. I'll round off. So this guy here on A does not give us this probability that we want. We are looking for something that will give us this probability. Okay, so we try B. So B, they're saying 0.5 deviations away from the mean. Okay, so when they just say 0.5 deviations away from the mean, they mean that the Z value can be less than the 0.5 or it can be greater than the minus 0.5. Here on A, they specifically said less than. No wonder I put less than here. But here they're just saying away. So away, it means the Z is in between. So that means the probability of the Z between minus 0.5, okay, and 0.5. So here we learned in the tutorial sheet that this is the same as P Z less than 0.5 minus, okay, P Z less than minus 0.5. Okay, so when we manipulate this by the complement rule and the symmetric rule, okay, we said, if you guys watch those videos in the tutorial sheet, we said if whenever Z is between two numbers and then one of them is positive, one of them is negative, you always end up with 2, the probability of Z being less than the positive number, and then minus 1. So this will just be 2. And then this probability here, I already found it was there, of Z being less than this. So I'll write 0.6915 minus 1. So now let me punch that onto the calculator. So 0.6915 multiplied by 2 minus 1, I'm finding exactly this probability here. Okay, which is just 38.3%. So this one that says 0.5 deviations away from the mean is the one that will give us this about 38.3%. Okay, so any questions there on how we found that answer? So the answer there is B. We pick B as the best answer. Okay, so if there are no questions, I'll continue to go to question, that will be question 17 now. Okay, question 17 is very easy. They're saying if Z is less than or equal to A is equals to this, then A is Okay, so here we just go on the Z table, look for this probability there. Okay, and then once I find it on the probability, okay, in case this probability is there like this, okay, if I find that probability, I'll go on top and then I'll go to the left. So I get this value here, I add to this value there. That will be the answer, okay, of that A there. So that is 0.6255. So let's go to the Z-score table here. Okay, so we are looking for um six. I've forgotten now. What was that? 0.6255. Okay, let me write it. 0.6255. So we are looking for this. The 0.62 starts from there. So it's here. So I'll go up, okay, and then I'll go to the left. So what do I get? Um, 0.3 plus 0.02. So that will be 0.32. So I'll go back now here, okay, and just select that. So this is the answer that I found, this one here. So this guy here, okay, is the same as the option on B. So we pick B as the correct answer. Okay, and then question 18, they're saying find the probability that Z is between minus infinity and positive infinity. So this one, okay, when you simplify it, it's just 2 probability of Z being less than infinity minus 1. Okay, so what is the probability that Z is less than infinity? So infinity is a very big number, right? Infinity is a very big number. So the probability of Z being less than a very big number, okay, is just always equals to 1. Okay, because when I go on my Z table here, okay, yes, you can see like the more the numbers are increasing, I start at 0.0 here. As I'm going down here, okay, what is the highest Z score? The highest Z score has 39 there, down, and then here on top it has what? That's 0.09. So 39 plus 3. This 3.9 here, plus that guy there, which is 0.9, okay, it gives me 3.99. So the probability that Z is less than 3.99 is this guy at the end there. Okay. So as the value increases, the probability just goes or tends to 1. Okay. So the probability of Z being less than any number that is greater than this, okay, or if I put 4 there, or 5, or 6, or whatever, the probability is just going to be equals to 1. Okay, so if the meeting cuts, just rejoin again using the same link. Okay, so there now we had what? We had the probability of being less than infinity. So that will be, remember this was 2 probability of Z being less than infinity. Okay, so I was saying here this probability is the same as 2. Probability that Z is less than infinity minus 1. This is 2. This probability here is 1. Minus 1 is equals to 2 minus 1, which will just be 1. So the answer there is actually A. Okay, so now here's the secret. Whenever the number that is there or there is greater than 3.99, then the probability will always be 1. Okay, so if, for example, they say probability, okay, that Z is between 5 and 5, like this probability is 1 because this number here is greater than 3.99. Probability, okay, they put 17. Z is between 17, minus 17 and positive 17. This one here is 1 again. Why? Because this number here is greater than this. Okay, so any number that is greater than 3.99, if you find its probability, it will always be 1. All right, so now let's move to question 19, which is on the T-score. So here they've given us what? They've given us T alpha over 2, comma, comma what now? I can't see, comma 2 point, okay, comma 2 point Okay, I can see what the, oh, okay. I've seen now. So here they've given us the t, then alpha over 2, comma 14, okay, is equals to 2.145. So find the value of alpha. Okay, so I want to find this value of alpha such that, okay, this t value will be equals to 2.145. So again, on that t-score table, I'm just going to look for these t values. So the t values are here. So if the t value is there, okay, on top here, I'm going to find the values of alpha. And then here, I find the degrees of freedom. So the degrees of freedom is 14. Okay, the degrees of freedom is 14. Then I'm looking for this alpha here. And then I have 2.145. So I just have to go on my t table. So this is my t table here. So let me write the thing that we are looking for. We are looking for t alpha over 2, comma 14, which is equals to 2.145. Okay, and then we are looking for the alpha. We want to find the alpha. So where do I have my 14 degrees of freedom? I have them there. That's my 14 degrees of freedom. So in this 14 degrees of freedom, I'll just start going to the left, okay, like this, until I find that value, which is this one, this value that they gave us, okay, the 2.145. And then I'll just go on top like this. So that one, since it's alpha over 2, okay, the alpha value will be found in the row for the one-tailed test. Okay, so I'll go where now? Okay, I'll go here. Okay, so cancel this out. So I'll go above here. Okay, so meaning that alpha divided by 2. Okay, so here you can find this alpha in two ways. Okay, you can find the alpha in two ways. So you can go to this one, which is above for the one-tailed test. Okay, if whatever you have here is equals to this guy, okay, and then you have 14 degrees of freedom, then you're going to find this t-score. Okay, okay, and then, or you can say this whole thing here, okay, comma 14 for the two-tailed test, again, is just 0.5 there. Okay, so to find the value of alpha, I'll just use this one here for the one-tailed test. So I'll go on top there. So I'll find this guy here. All right, so it means whatever was here where there's alpha over 2 is this 0.025. Okay, so let's go back to here. So it means there, what was here was 0.025. So it means t, this alpha over 2 is actually equals to the 0.025. And then comma 14 is the one that gives us the 2.145. So now I want to find the value of alpha. So what do I do? Cross multiply just there. Okay, so it will be alpha is equals to 2 multiplied by 0.025. So that will just be 0.05. Okay, so alpha is 0.05, which is the same as 5%. Okay, just multiply it by 100 gives you 5%. So I pick A there as my best answer. And then we have a similar question on question number 20. So question number 20, there we are finding the degrees of freedom. So they're saying T of 0.05, and then degrees of freedom is giving me a T value of 4.015. So what is the degrees of freedom? Okay, so again, we have to go to the T table. Okay, so on this T table, my alpha is 0.05. So my alpha is this guy. So I'm just going to go in this, what am I going to do? I'm just going to go, what was I given there? Okay, because I can't seem to find the 4 point something there. Because the 4 point somethings, they're starting from here. I can see 4 point something, 4 point something, just like that. Okay, so 0.05 And then I'm looking for 4.015. So where's the 4.015? Let me make this disappear. So among my t values, okay, I'm looking for 4.015. So here, where can I find my 4.015? 4.015. Okay, can't see any. Guys, can you see where there's 4.015 there? Because I can't see any there. Okay, or a value that is very close to this. Um, okay.
There before
Before what? I can't see it.
there's like degree of freedom
This is funny. It's where,
as the degree of freedom is still now on the far end where there is 0.001
oh, yeah, yeah,
along
yeah.
the degree of freedom which
This
is
one, right? Uh-huh. Now, this one here, uh, I think it can't be the answer there. Because what we've been given here, are we going to find the answer there? Because what we've been given here is look at the area that we've been given there, or the significant level. The significant level there, we've been given 0.05. Or maybe they made a mistake, right? They made a mistake on the significant level there. Because they gave us 0.05. And then they want us to find the degrees of freedom such that this t value is 4.015. Okay, so maybe they made a mistake on this value here. Because when I go where I have the significant level 0.005, I can't find any 4.015. So, for example, if I go, let me erase this. So then they gave us the significant level of 0.05. So these values are at two places. So when I go here or there, when I check this column here, okay, I can't see any 4.015, this column here, all the way to the bottom. Yeah, there is no 4. And then even this one here, that also has 0.05. If I check in this column, okay, I can't see any 4.015. So the only one that makes sense is this. So it means they are on the significant level. They should have put this guy here, 0.0005. That's the one that works. So if I have t of 0.0005 like that, and then comma, the degrees of freedom 16, like you said here, okay, it's the one that is going to give me 4.015. Okay, yeah, so that's how that one can work. Because if my significant level is 0.5, here I can't find any such t value like this one here. Okay, so where am I going now? If I go back here, 16 would make sense there. Okay, no wonder it's even there. So the 16 there would make sense because that's where I can find such a t value. We only have one such a t value on the t distribution table. All right, so we'll move on from this one. So there they made a mistake on the significant level. It should have been 0.005. Okay, what about this one? They're saying we use the t distribution when, okay, so we all know here we use the t distribution when the population variance is unknown. Okay, so when the population variance is unknown, this guy here, that's when you use the t distribution. Okay, and then the central limit theorem suggests, okay, that whenever, okay, suggests that whenever n is large, then x is normal. So we get that. So, but how large? N has to be greater than or equals to what? To 30. Or in short, they just say n has to be greater than 30. Okay, so when n is greater than 30, meaning the sample size, you have more than 30 samples, then the x of whatever distribution is just going to follow a normal distribution. That's what it means there. Okay, what about question 23? They're saying in a 90% confidence interval, we use the significant level as, okay? So here's the trick. When I say confidence level, okay? When I say confidence level plus the significant level, this here should always give me 100%, okay? So now the confidence level here has been given as 90%. So this is 90% plus significant level is equals to 100%. Okay, so significant level will just be equals to 100% minus 90%. So that will just mean significant level is 10%. But 10% is the same as 10 divided by 100, which is just 0.10. So we come here and pick B as our best answer. Okay, so always know you can find the significant level given the confidence level, or you can find the confidence level if you've been given the what? The significant level. The only thing that you have to know is that when you add those two, you should get 100%. Okay, when you add those two, you should get 100%. All right, and then 24, what is the use of the margin of error in a confidence interval? Okay, so I'll just write one formula for maybe the confidence interval about the mean will be x bar plus or minus, we have your z alpha over 2, then multiplied by s over root of n. Okay, so when I was teaching this in the tutorial sheet, I said this part here is what we call as the standard error. Okay, and then when you multiply the standard error and the z-score, or the standard error and the t-score, you get the margin of error, which we just indicate by E like this. Okay, so the margin of error, the use of it, okay, is to give the width of the significant the confidence interval. Okay, because remember, to this sample mean, we're going to add this and stuff, or we're going to add this to find the upper bound of that confidence interval, and then we're going to subtract this to find the lower bound of that confidence interval. Okay, so by doing so, it helps give you the width of the confidence interval. Okay, so I remember in the tutorial sheet we even had questions where we are reducing, was it the z value? Yeah, we are reducing the z value so that when the z value reduces here, it means the margin of error reduces, and then we are seeing that the width of the confidence interval was getting shorter and shorter. Okay, so it's very important for the width of the confidence interval. So we pick A there as the best answer. Okay, and then here they're saying in hypothesis testing, that's question 25. Okay, in hypothesis testing, um, 2.5% may be used as alpha. So alpha is called the significant level. Okay, so the significant level is alpha, and it is represented by alpha, this guy, alpha. That's what you call the significant level. Okay, and then we move to question 6, 26, 27, and 28 on this page. So the distribution of sample deviations S is called the sampling distribution. So this one is straight from your notes, okay? Whenever you are talking about the distribution of samples, just know that it's a sampling distribution. Okay, and then now we are on question 27. Okay, so question 27 is about the the errors that we can make when you're doing hypothesis testing, okay? There's two errors. So there's type 1 error, and then there's type 2. Okay, so what happens in a type 1 error and what happens in a type 2 error? Okay, so anyone who can help us, what is it? What is a type 1 error? What is a type 1 error? Anyone who has who can help? Okay, so
Type 1
oh,
error,
okay.
accepting a false hypothesis.
Okay, you're saying type 1 accepting a false
A
hypothesis.
false hypothesis. Now a hypothesis.
Okay, so accepting a false hypothesis. that is um that is a type 1 error. Okay, so in other words, what you said is correct. Okay, or we can say a type 1 error is rejecting the null hypothesis when it's true. So I've just said I've just said what you said, but I've said it in another way. Okay, so rejecting the null hypothesis when it's true, that's a type 1 error. Or you can say what you said, accepting a null hypothesis when it's false. That is also a type 1 error. Okay, so you can define them like that. So here they're saying which of the following is a wrong decision in hypothesis testing. Okay, which one of the following is a wrong decision in hypothesis testing? Okay, so part A, they're saying accepting HO or H naught. So H naught is a null hypothesis. So if we accept H naught, is it a wrong decision or it's a correct decision?
Yes, it's a correct decision.
If we accept a true null hypothesis, is it correct? Okay,
I
so
know it's wrong.
why is it wrong?
I'm thinking about the type 2 where it says failing to reject a false hypothesis. Oh, okay. It's the first one is okay, sir. I've got
Okay, and then B, they're saying failing to reject a false null hypothesis. So if we fail to reject a false null hypothesis, what type of error are we committing? Are we committing type 1 or type 2?
type 2.
Type 2, right? Yeah. So that is uh, failing to reject a false H. That is a type 2 error. So that's actually a wrong decision because we are failing to reject a false a false H naught. I mean, if the H naught is false or the null hypothesis is false, then we must reject it. So here now we are failing to reject it. So that's a wrong decision there. Okay, so this guy here, I'm pretty much sure it's the answer, but let's go through the others. Here they're saying rejecting a false H naught. Yeah, so this is a correct decision. And then here they're saying failing to reject a true H naught. So failing to reject a true H naught is also the correct decision. Even this one is the correct decision. So the only wrong decision here is on B. Failing to reject a false H naught. That's a wrong decision. Okay, so that's what we pick. So the answer is B. And then question 28, they're saying the null hypothesis emphasizes no difference. So the answer there is just no difference. Okay, it has no effect. No wonder when you are writing the null hypothesis like this, you may be saying that the mean is actually equals to maybe 10. Okay, and then your alternative one is going to oppose this. It's going to say the mean is not equals to 10. So here there will be an effect, okay, or there will be a difference. But here there will be no difference. Okay, so the null hypothesis emphasizes no difference. So pick A there as the best answer. Okay, so these two more things actually make sure you go through them, okay, because they can confuse you time. All right, let's look at the last two questions, which are on this is what now? This is question 29 and 30. Okay, so here they're saying what is the fifth stage in hypothesis testing? Okay, so the fifth stage is just decision making. So after you've done everything, you've tested, okay, you've made your conclusions, and then now you make a decision. So this one here is the fifth stage. And then 30, they're saying in a distribution where both population deviation and sample deviation are not known, which of the following is best to use? Okay, so you always use the T if the population deviation is not known. Okay. All right, so that's it for these questions here. Unless you guys have some other questions, I can address them. Okay, so don't forget I said I solved test 2. Test 2, I've already uploaded it. So this is test 2, question 2, and then question 1 is there. So I'll arrange them nicely so that it's very easy for you guys to find whatever you want. Okay, so from here, we've done test 2 and those random quizzes, right? That someone sent me who is doing online distance learning. And then we've actually done test 2. So what we are remaining with is quiz 1. We are going to revise it. Okay. Quiz 2, we're going to revise it. And then test 1, we're also going to revise it. And then once we are done with this, we go to the exam past papers. Okay, so that when you'll be writing your exam, you've gone through all the tests, you've gone through some past papers, and you've also gone through what? Tutorial sheets. Okay, so don't rest. This is the end of the journey. Okay, I saw your exam timetable is out. I don't know if you're starting on the 24th November, the exams. Okay, but no resting. If you are sleeping, stop sleeping. Just be studying right now. Okay, so that's how we are going to move. So tomorrow, I plan to do quiz 1 and test 1 tomorrow. Okay, and then the other day we can do quiz 2. And then after that, we start straight to the past papers because all the tutorial sheets were already solved. So you can go through those at your own time. All right, so thank you so much. I'll end here. All right, so and don't forget to join our live classes. Okay, so we're having everyday live classes until you write your exams. Okay, so if you're interested, please feel free to register with us. You can check out the link in the description below here. It's going to give you a video registration guide. You can watch it to know how to make the subscription so that you can be part of these live classes. Okay, and then once you're part of these classes, trust me, guys, you're going to pass. Okay, you're going to pass if you've been having any challenges. Okay, so you can see here there are past papers. I'll be uploading more past papers here. Okay, if you want, you can go to the folder for the tutorial sheets. Okay, again, I'll be putting. I almost said I'll be putting more tutorial sheets, but all the tutorial sheets are already solved. Okay, so you go there on the tutorial sheets. You can access these things at your own time, at your own pace. Okay. And on our mobile app, you can actually download these videos and be watching them offline. Okay, at any time, anywhere, even in your blanket. So you can see tutorial sheet 1 to 7. The full videos are there just waiting for you. All right, so bye-bye.